configured, and then when it gets written to, it gets moved into additional buffer pool cache, processed normally, etc. So this is kind of giving you a bit more resource memory-wise by kind of giving that near memory speed from buffer pool extension. And there's a quick kind of slide to show you kind of how that works. I suspect that most people will probably have encountered an I/O related type problem, and there's a whole bunch of kind of I/O demos. Effectively, there's only a few DMVs available here. I want to just quickly jump over to some demos now. Effectively, hopefully it works this way. But I/O virtual file stats is effectively the way that we can specify all databases or a specific database and a specific file ID. For example, the file ID number 2 will be your transaction log file. You may have other transaction logs, I don't know why, but number 2 is the first is the primary data files, number 1. Then you got the transaction log number 2, and you might have a bunch of secondary files, secondary data files that go 3, 4, 5, etc. So we can specifically look at individual files here. So I'm going to basically look at the I/O virtual file stats one there, and let me jump over to the screen again. I'm just looking at the time that we have. We have about 10 or 15 minutes. I think about 10 minutes left here. Now hopefully this will close up. Ignore that warning. This is my demo environment needs to be rebuilt. So where do I need to go to? Okay, I think I've lost the query. Let me just bring up the one I want. So yeah, there we are. Okay. So this basically again is one of the queries that I've kind of I've modified for the demonstration from Glenn Berry's diagnostic that originally was based on Dewey May's code. And what I've basically done here is I've filtered for, let me just bring it up a little bit higher to show you, filtered for a specific database. So I basically, I don't want to move that, let's move it back, for a specific database called EventureWorks 2014. I'm just going to run this here now, and I've got 2 bits of information coming from here. One is it's telling me the data files, volumes, the drives, where EventureWorks is listed on. So I've got LNG. L, I think, is going to be the transaction log, I think in this case, and G will be my data file. But notice I also have another set of queries below that show me what the read and write latency is. Now, latency is the key bit of information we're looking for here. It's telling us kind of how fast, on average, that response is coming back to that. So in this case, I've got some SSDs in this laptop that I'm running this demos on. So I've got kind of 2 or 3 or 4 milliseconds, perfectly fine. Anything below 10 is going to be probably acceptable for most people. When you start seeing 20, 30, 40, 100, 500 milliseconds latency, you effectively are waiting quite a lot for those IOs to complete their kind of round trip requests back to from disk to memory. And also you might find that kind of the number of actions. So here, I can see for EventureWorks we've got 1 and 1 for the log and 5 and 4 for the day. So that's pretty good. That's normal. That's not too bad at all. But if I look at kind of the overall, it's slightly different numbers. So what you might find is that one specific database is giving you certain performance characteristics problems. It may be that it's highly fragmented, or there's some other reasons for that. And you may want to balance the performance. You may have one drive that's really, really poor, and others are really good. So you may find that you're just being hamstrung by performance because of one specific drive that's basically substandard, or it has problems that maybe needs to be addressed. Maybe it's got partition offset problems, that kind of stuff. So be aware that DMOS virtual file stats allows us to kind of work into that and give you that level of information. Make sure I just have any more demos in that one. Oops, let me go to the right folder. I think that was the only one I want. And actually, while we're here, I'm going to bring it up the next one here, which is the memory one. So effectively, what we have here is some queries around the memory. Now, some of you may have already previously used something called DVCC memory status. and it's a fantastic piece of code that's been around for a while, but it's a little bit chunky to kind of process. So a while back I found that Tim Chapman from Microsoft did a nice little PowerShell script that basically allowed us to kind of process that into something we're a little bit more kind of familiar with, which is a table structure. So effectively, what I've done here is I've just leveraged that for this demo to process this PowerShell script to process and run data into a table in the AdventureWorks database on this specific server. It takes a couple of seconds to run, and then I'm going to make use of, actually it looks like I lost my connection. I'll just let it run again. So it's basically going to kind of repopulate the DVCC memory status output there. So that looks like that ran fine the second time. So I'm just going to make sure that I have that information available. Right, I have that. So we've got a kind of a better way of viewing the DVC memory status. And you see there's 192 different roles there. What I'm going to do is I'm just going to pull to the bottom of one of these and actually use this specific query here, just as a demonstration one. So what I've done is I've just done a bit of a pivoting table process on here to show me kind of, actually probably a better one to do is probably this one here. Let's have a look. Okay, so this is showing me how many pages are locked in memory. So I don't have locked pages in memory set on this server, and I can see that I've got, you know, different number of pages allocated, but this is not locked pages in memory, and I can see here that it's a VM committed, so this is a virtual machine, and this is the reservations for the memory manager. So this would tell me if I had locked pages in memory, these numbers probably would move from here, mostly to there, but there'd probably be a few left in there as well. It tells me effectively what there is happening on the system. Here's, for example, one where I pivoted the different locks available. So this is using the DMOS performance counters, so those perform counters that we're all familiar with, and effectively I'm kind of doing a breakdown about the average wait time. Then this is in milliseconds, and you see here that, you know, we have a lot of key waits going on, which is not unfamiliar. It would be probably around these two that I would normally expect to see them, but I may find if I capture this over kind of intervals and run this, I can actually see what that is between two sets of timestamps, for example. Capture some data, wait a bit of time, capture some more data, do a delta on that, and then do this analysis against that delta set. And this would tell me what the average time is. So it's a great way of kind of getting that level of information available. I'm going to just have a quick look, see if there's any other ones here that I probably want to show why before I jump back. Probably don't have any implicit conversions on this demonstration, but here I'm going to show you a query that is going to be made available as part of the outcome from this session. Is we're basically looking at the query stats, the query plan, and the SQL text, and we're joining those together using cross-apply. And effectively what I'm looking for here is implicit conversions. And implicit conversions are effectively when data types are not matched. So effectively, internally, in order to process that, it's got to do some extra work, and that extra work effectively is for every single row of data it's going to process. And this can really make a performance difference. So if you have any queries that have implicit conversions, any plans that is rather, that are utilizing implicit conversions as part of their process, then this is a great way of identifying that with this code, and you can basically go in and see, you know, do I have to modify the structure of the query itself to remove that implicit conversion? Why is that? Maybe the input parameter is a varchar 10, and actually it's a you know, really a varchar 20 or some other kind of combination. Maybe it's coming through as a, you know, a numeric, and it's actually an int it needs to be. So these are the kind of things you can cause an implicit conversion here. Let me just jump back to the PowerPoint slide. So we won't go through the locking DMVs because we probably don't have time, but I want to talk about the indexing DMVs because this is one that also normally is when you're doing performance tuning, indexing and getting the indexing strategies right can make a huge difference in performance. So there's a whole bunch of indexing DMVs that we can examine to understand how those are being processed. And what we can also do then is look at what is the maybe missing indexes that can cause us, some improvements in performance. What is the partition usage stats of an index? So how many times have we updated and maintained that index compared to how many times are we using it? So do we have any kind of overhead in play that we don't really need to have? So let me see if I can kind of quickly bring up the demos for those. And hopefully this will be back in a second, and I'll just bring that back up to the indexing. Where was it? I got it there. Okay, let me go and collect that one. So we basically have, for example, this specific DMV here. Let's say yes to that for side. And effectively, what we're going to do is we're going to look at, in this case, what's known as the missing index DMVs. So there's a whole bunch of them. They make it nice and simple for us. So basically, there's 3 different DMVs that we need to bring together: the DB missing index group stats, the DB missing index groups, and the index details. And there's some other index DMVs we're talking about here. What I'm just going to do is just literally run that. So effectively, at the moment, I'm looking for this specific database, but I'm in master at the moment, so that's not really good for me. So I'm going to move to 2014, and I'm going to now run this for 2014. And you can see here now, I've got a list of what it thinks are the table structures, along with the inequality columns, the equality columns, the included columns, how many times that these have been kind of compiled and seeked, the last times, etc., and the impact usage. So these are the ones that maybe we want to consider, and effectively then what we will have is, let me just copy one of those there, just jump it into a new window. No, something that we can effectively try out in our test environments to see if this helps with performance. So notice it has a nice natty little name, the way it's kind of added in some extra information there. So you probably want to change that. But here it's saying, you know what, we want to add it on the modified date column, but we've got a whole bunch of includes here. Now, SQL Server is fantastic for saying, you know what, I'm going to recommend a new index to cover this. It ignores everything else that's in the environment, and it gives you a bunch of includes. So have a look at what you already have. Have a look at how that's configured and put together before you start applying this. But it's something that you can kind of help.
Hey, Neil.
I can see that we're on the kind of the 9 o'clock time.
Yeah, unfortunately, with all the back-to-back sessions, we're kind of at that time limit. Do you have a slide with your intro or your information on it? Would be also handy.
Yeah. So I'll just bring up this the end slide there. So that's included in that information. We won't go through that one. Here's some resource links. I'm about 2 minutes away from. What I'll do is I will go through and put my information available. I'll send this to you right in the slide deck and all the information available. So if we have any questions, I can kind of take those offline and answer those and put together all the scripts for the session today as well. So I know we started a couple of minutes late, so
that would be great.
There we go. Contact information.
Yeah, there we go. That's
so if you need to get hold of me, you want any questions around DMVs, please do kind of tweet to me, send me an email. So you can get me at neil.hambley@hotmail.co.uk, or just tweet to me at neil_hambley, and I will definitely kind of be happy to answer questions around this. Ryan, thank you very much again for allowing me to present again at this Palooza. I know you need to jump on to the next one, so I'm going to be quiet now. Thank you.
Yeah, thanks, Neil. Yeah, I will get all of the questions. Everybody that has submitted questions, I will shoot those over to Neil so that Neil can blog about those when he gets a chance. And you've got his contact info here, so you guys can look him up and hit his blog and read that. And we'll try and send a link out as well. And of course, the recording and everything will be available. And with that, Neil, thank you very much for taking the time to speak with us today. And we will catch everybody on the next session, which is starting right now. Thanks, folks.